Hello everyone, welcome to the joint webinar with D# and Datacore Consulting. You can see the title of the webinar here. It's Stop the Backlog Spiral, Real Ownership for Scalable Delivery. And let's start. So here are the topics for today. We have 1 hour and we have some time in the end for the questions. And if you want, you can type your questions on Q&A or chat panel in the Webinar Geek platform you are hopefully seeing in your screen. First, we have opening and why data backlogs are a symptom, not a problem. Then Juha Korpela will share his thoughts about this, and then it's my turn next. We are doing case how D# enables delivery without dependency. And in the end, we have this Q&A session here. The presenters today, we have Juha Korpela, who is data modeling enthusiast and independent consulting from Datacore Consulting. And myself, I'm Tero-Matti Kinanen, I'm CEO of D# Data Solutions. So the two of us are speaking today, and I will start with some introduction first, then it's Juha's turn, and after that I will continue. So, why data backlogs are a symptom, not a problem? Typical situation, what you find usually in many times in your data team is that the requests pile up and the backlog just grows. And the problem is that the system that you probably have built is fragile. The data delivery might be manual, it might be sometimes even handcrafted. Every solution you are finding in your data platform, every solution is custom, but and not standardized. And there might be no separation between modeling and implementation. And the same questions, same topics get rebuilt again and again, but every time differently, depending on who is building them. So I'm not suggesting you all have these problems, but you might have at least noticed that sometimes you have some of these problems, and you might find that you are scaling the chaos, not solving it. And now, having this introduction, I will hand this to Juha to continue.
Very good. Thank you, Tero-Matti, and hi all. Good to be here. And what I'll do once I get the screen share going is I'll try to kind of place this whole problem in context of sort of data development process and in that sense. Not necessarily a technology problem, but rather a problem of how we deal with data development. And the way I see and the companies I worked for previously is that the usual process and the architecture just looks something like this. So architecture there is, but you form onto which you build some sort of solutions, which might be data products or might not. And you have some kind of a use case then eventually that you hope that data will be used for. So kind of value is going to be then created from the solutions you create. But the problem this whole kind of ownership question and everything is that for us data people, the development process looks like this. So we take data from the systems with the whatever architectural layers we have, and then we end up publishing that database basically in some sort of a data set somewhere. And the kind of delta care of this problem. So in a way, and the development process is very sort of one directional. It's very simple. It's very straightforward for us. Of course, we have all sorts of technical details, problems that we love to hate, but this is still something where we leave out the actual end result, which is the actual use case. But if we kind of try to rethink this a maybe sort of wider scheme, we have at the end some sort of value creation. There's some kind of a reality in which that business operates. Let's say we are in, I don't know, healthcare, for example. So there's patients to cure, and if we are as products, and there's some kind basically derive the need for the data solution. And this is kind of the actual end-to-end process. It's not just we care. Process doesn't end in publishing data. It actually ends in value being created. And what this means from a process point of view is that the process should look something like this. And I'll get in sort of see from right to left. I've been using this kind of way of describing this process now for a few years, because my former colleague Marit Salminen, who might describe that when we see on data, we as data people start working on data. We actually have
sorry to interrupt.
Start at the end, where we usually think
sorry to interrupt.
Yep.
Your voice is cracking a little bit. Maybe you should turn off the camera video. Hope that helps.
Let's see. Yep, let's do that. Anyways, so getting back to this, so the idea here is that we need that data development process to start where we usually think it ends, right? So the first question for even us data people, the first question should be, how does the business actually make money? And this is at the actual business end of things, right? Then we should think about the next question. Okay, so in terms of data, then how does this kind of materialize? So how does the business make money? What things exist in that business to make that money? And what does the business need to know for the use case we have in mind? And now we are kind of moving from the value creation to the business reality at hand to the use case that we need to be solving. And this is the beginning of the design process. And from this point on, we have the understanding of the needs of the data, that the data needs of the business that we need for this use case, based on which we can then decide what sort of a data product, whatever data solution that is, we need to build. And up until this point, we shouldn't think anything about the, in any ways, basically, the source systems. That doesn't really matter. We are thinking simply about value creation and the needs of the actual business, figuring out the product design part of this. So what sort of products they need. After that, we start getting closer to actual kind of technological data work. So depending then on our architectural choices, do we have data warehouses? What do we have? We start thinking about data integration and the layers of the architecture. So what is kind of the pathway through which we get this data, and eventually then where in the source systems the data exists. And of course, then now we have kind of looped around to the end at the left-hand side. So we've done this design path basically from right to left, after which we can start doing the actual implementation, the development process, which basically then just pushes the data from left to right to actually fit the needs that we created in the design phase. So this kind of an approach means that we actually need to also consider data modeling in two different kind of contexts. And in data modeling perspective, we need to have a business focus first and then an implementation focus, meaning that the initial modeling of the data need is actually focusing on what the business looks like, rather than our technical platform schemas and so on and so forth. We focus first on the business alone, and based on our understanding of that business at the conceptual data modeling level, where we model the business entities, and then based on understanding what we have from the source system, we should be able to create these kind of implementation focused models, which then define that, okay, this is exactly what we're going to be implementing. So this is now at the core of this kind of design development loop that we need to do, that we also do data modeling separated into business focused and implementation focused work. And now we're getting to the kind of final part of my part of this, and the actual important part regarding today's topic, which is about the backlog spiral and everything, because this also means that the work we do here can actually be split into kind of different parts according to who owns what. And it's basically something that I've tried to kind of explain briefly on this slide. The idea is not that the data team has a backlog. That's kind of wrong. The data team is basically responsible for that platform there and those pieces and bits and pieces there, but they don't own the use case, and they don't have a backlog for that use case. If we think of products and product ownership, you can think of context like Scrum or whatever agile method you choose. Product ownership means that there's someone who owns the product and someone who decides what should go in that particular product. And being a product owner means that you have to understand what are the needs of the actual business stakeholders who have that use case. So when we approach this design and development loop this way, we are also able to kind of assign responsibility and backlog management at the right level. The people who have to be involved in the design part are actually the business stakeholders and the product owner primarily. They have to define that because of this use case, we need this kind of a data product. And only then, basically, the technical details are involved into this process. And what I'm seeing in many organizations is kind of a awakening to the fact, perhaps, that data team backlogs are getting full. They are data teams, centralized data teams are bottlenecks. This is something that everyone understands, but there's perhaps some distaste in kind of relinquishing control of that backlog management. But that's exactly what we should do. We should find that part in the middle between the business and the data teams, those product owners. You don't necessarily need to subscribe to the idea of data products as such, or data mesh or anything. I think it's a philosophical point of view of how you want to build your operating models. And that relates then to how you do your modeling and how you do your data solution design. But the backlog should be at the product level. It should not be at the team level. That's kind of my summation of this part. And of course, if you want to build up this in a scalable way, and you have hundreds of data products and you have hundreds of product owners and all sorts of stuff like that, then you end up perhaps with something like data mesh, which is basically just scaling this idea to way larger scale with domain teams and so on and so forth. But that's not necessarily what you have to do from the very beginning. You just have to figure out what product management is versus team backlog management and focus on the product management part. So that's my sort of philosophical approach to data modeling and backlog management, and how we should share these responsibilities between data teams and product owners. Maybe Tero-Matti, you can take it over from here.
Yes, sure. Thank you, Juha. That was excellent, and I will now share my screen and continue from here. So let's start this. I'm going to show you what's in my agenda. So I'm talking about these things today. So business-driven design and development, then some example implementation in D#. Then I have a small real-world example and some ideas about the process, which Juha actually showed there. and finally some things about culture, how to do things, and finally a couple of words about D# as a company. So let's start. We actually share a lot that Juha showed in theory how we should manage the data products. This is a basis of our methodology and what our software actually supports. We always say that in your data platform, in your data project, if you're doing a data project or data product, you should always create a business model first. And the development must be business driven. And when you build the business model, it will be the common language between business and IT. After that, you only map your data wherever it is. You just map the data to the business model, and then you press the button in the software and you automate the business model driven data platform. And when this is done correctly, you will really enable the real data warehouse automation, and you can really have the leap in productivity. And finally, I want to say that in our methodology, we always say that build it iteratively. Don't try to solve the whole world's problems at the same time. Try to solve very small piece of it. The fundamental nature of data project is highly iterative, and we should have a methodology and tools that support full automation. And you should have architecture that is agile and supports that kind of data injection, data loading and stuff like that. For example, data vault, which I'm today talking you about at least some of its aspects here. The development is continuous, not one time. So that's the basis of agile project management here. So what is business modeling? This is an example model that we are using today, and we will dive a little bit more details later on. But it is the mutual language between different business units, management and IT, and so therefore it's the foundation of your successful data platform project. You should have real world terms like person, gender, project, accounting entry, account. When you do this, you should model your business. You should not model what are your systems, where the data is. That doesn't really matter. You will later on combine the data to this model, and therefore you will get with automation you will get a good solid data platform. So business modeling is like this. Also, with a good business model, you should have a you should get a quick idea what the model is about. For example, you see these colors here. These represent types of classes, and these red ones here, they are classes that you have events. You have something that has timestamps or validity dates or something like that. Things that happen, and you get more and more data for those. These are most likely something that if you are creating a reporting project, these will probably become the basis of your fact tables then. The green ones here, they are party place things, something very real world examples like person here, and they are something that you can find in the real world. The blue ones are descriptions, so like lists of things like accounts here. You can see that it can be list of accounts in your bookkeeping, account number and account name, and so as an example. And then you have also other types, a little bit difficulties, role classes here, which are typically in between a couple of classes here. But that's briefly about the colors. But the colors will help you understand visually what's going on with your model. And you probably know a lot about the architecture and how you build things. This is similar what Juha showed there. You have source systems on the left, and on the right side you have something that where you want to use the data, and you in the middle you have the data platform that actually unifies the data and makes it usable. And here you have the layers. Juha had in his picture had this medallion architecture with bronze layer, silver layer, gold layer. These are the same in all successful data modeling techniques. For example, we call them storage layer, which is similar as bronze layer, or in data vault it can be the raw vault. We have model layer, which is in medallion architecture, it is the silver layer, and in data vault it is the business model. And then on top of here we have the publishing layer in silver in that medallion architecture, that's the gold layer, and then in data vault that's the information marts. So that's the idea of these layers. Good advice is that you should have those layers in some form or another. It helps the reusability of what you are doing there. And in our case, we always start with the use cases, and we always think that what is the requirements? Why are the users requesting us this kind of data? What information need there is? And then we do the modeling and mapping, and then we press the button, and this middle part here is created automatically. And when you do it like this, you have this model, and you are doing this with automation. Then you are also not only you are free from your systems that you have because the model actually makes you independent of your systems, but you are also getting independent of the technology platform you are implementing this data platform into. You can actually just select a target platform, for example, Azure SQL database or Fabric data warehouse or Postgres database. You can just choose that, and our tool just creates the code for that selected platform. So if we take a look at how it actually works, so let's take a look how things work in our example model and explore the details in small part of the model. We have this small part here. We have this person and gender class. And as you can see, we have not only the classes, we also have these attributes. We are always modeling also the attributes because this is actually the basis of the automation. And this is actually, you are defining what the end user is seeing in your solution in the end. That's why you always do the attributes here too. So this is not only a conceptual model, this is also a logical model, what you are modeling here. And we have this person class and we have this gender class here. With person, these attributes, gender, these two attributes here. And when now we have the model ready for these two classes, we should take a look at the data that we want to combine. And we have this situation that we have the person data coming in from separate source systems. First of all, we have this person master system where we have this person table with this kind of example data, and we have this person ID, we have last name, first name, nickname, date of birth, and then we have gender ID, which actually looks like a reference to another table. And yes, it is. If you look at the gender table, you have these same gender IDs here and names for those IDs here. So basically, this person table should be mapped to the person class, and this gender table should be mapped to the gender class. But it's not that easy. We do have this person data in project master system also. There's a table called person there too, and little bit different data there. We have person ID, we have last name, first name, date of birth. We don't have nickname. We don't, like we had in the person master system, we don't have gender ID. Okay, we have to manage with what we have. By the way, if you take a look at this, there are some, might be some same persons here. For example, this Carson person here is in the same systems. Same person in two different systems. So we have to take care of that too. And actually, in our case, it's very easy. But if you're doing it somewhere else, something else, you have to take that into account. And then we do have this third system too, this HR system. And in the HR system, there's a table called employee. And within the employee table, you have employee number, you have person ID, last name, first name, birth date. So you have similar data. All these three tables should be mapped to the same person class. So what are we going to do? All we need to do is to connect the different sources to our classes in the model. So what we do here, we map the person to the class person, gender to the class gender. So as you can see here, we have this schema of the person table and the gender table here, and we are just mapping it to this class, and all the properties are lining up nicely. Then we do the project master mapping, the person table. We are mapping to the class person here. So we have this schema of the person table in this ProMaster system, and we map what we have. Not all properties, but we map what we have. And there you can see what is mapped there. And then we have this HR system, which is mapped to the class person here. But as a notice, if you take a look at the bigger picture, we are also mapping the same data to the employee class as well. So you can reuse the same source data many times if it's needed. So now we have the mapping done for all of these. So what happens next? We just push the button, and this is what you get. DSAP Studio generates the full data vault implementation based on the model and mappings. You don't actually have to model the data vault. If you don't like data vault, you don't have to like it. But for us, the data vault is the really good alternative for the storage layer because it has good benefits like time traveling, storing all history data, and stuff like that. So it's a really good way to store the data. It's not a good way to use the data, and I will show you also the good way how to use it. But this is actually what you get only by doing the model and only by doing the mapping. Our system automatically creates the good data vault structure. It creates the hub table, it creates 3 satellites, one for each source system, and then it creates the point-in-time table as well, which allows as the time travel there. So you get hub table, 3 satellites, and point-in-time table. But you always get this model layer or business vault object as well called cPerson, which looks exactly what you have modeled in your model, and this is something that gets the data out of these satellites, this hub, and point in time automatically, and makes it very easy to use the data because now it's combined and it looks like exactly what your business model looks like. You don't have to dive into this data vault structures if you don't want to. Of course, it's possible if you want to do that, but you don't have to. And here is what you can see from the tool also that what is the full data flow. So you have these 3 source tables. It goes to the working tables for pre-processing, and then it's stored in these 3 satellites and this hub. And this hub is of course because we can have this same person in these 3 different systems. This hub actually keeps track that and combines them, so you can see the one person only one time, and you can see the C person view that is created, gets the data out of these 4 tables here. So to see the bigger picture, the full model layer with all these C person and all other C classes there too, it's exactly like the model. You are storing the data in Data Vault, but you are using it through this Business Vault or Silver layer, if you want to call it Silver layer. Automatically, you can do that too. So you don't have to use the data from raw vault structures. It is automatically visible as your model classes in a model layer, or Business Vault, or Silver layer, or whatever you want to call that. You also, what you are getting automatically, you will get all needed things for implementing. All physical implementation of your data platform is created for you automatically. You get all the tables, you get all the views, you get all the pre-processing and loading procedures and orchestration procedures as well. So this is an example of what you're getting for the person class. All of this is automatically created for you. For example, for the hub, you are getting 3 loading procedures for the hub because data comes from 3 different source systems. And for each satellite, you get an own loading procedure. For point in time, you get an update procedure for that as well. If you want, you can take a look what the SQL code is like. So it's you don't have to write any of the procedures yourself. You don't have to create the tables. You don't have to create the views. It's all done automatically. And you can of course take a look at the code before you are implementing it in your data platform, if you want. So the full implementation is really created automatically, and the incremental installation package takes care that nothing gets broken. You can always create again the full model or part of the model, or add classes there. They make changes, take out attributes, create new attributes. Everything is installed automatically, and it never gets broken. It never gets deleted. So that's a very nice thing to know too. Orchestration procedures are created automatically, and one addition is that you are getting a data catalog also updated in the database with all metadata. That's also a possibility if you want to have that. So from the source model, the business model, you are getting the full data vault model, which can look like something like this. So you are getting this automatically. And as a recap, you always start with a business model, like Juha showed in his presentation earlier. You start from the top right position. You start thinking what is the customer need, how are you going to achieve that, and finally get into that. You do the model and with a need, and then you dive into the data and see where the data is and combine the data there, and what you are getting is the full data warehouse solution automatically. One real-world example. This is a project that one of our customers started 2 years ago. They went into production pretty soon after the development started with smaller number of classes. I think the first one was something like 20 to 30 classes where they started. This is an example of very typical submodel that they are building. This is like emergency. If there's an emergency happening, and for example, ambulance or firefighters are going in the field. So how is it modeled? So this is how it actually is modeled there. The actual model with customer is in Finnish because the customer is Finnish customer, but here I translated for this example in English, so you can take a look, a little bit deeper look what it looks like. There are currently, it's iterative development. There are new use cases going into production continuously. Currently, they have 100, a little bit over 100 submodels, all something like this, some a little bit smaller, some a little bit bigger. In those submodels, there are 400 classes. These are different types of classes they have. They have published different infomarts. They have 80 fact tables there, 330 dimensions, and they have 8.5 billion rows of data, and together that's 4.5 terabytes of data. And as I said, it's iterative development. They have in development now into like 200 classes right now, and those will eventually go into production, some sooner, some a little bit later. Data is loaded from source systems daily, and the model and the implementation is created automatically with C# Studio, and the data is stored in data vault format. I haven't talked too much about the processes, so I want to tell something about that too. So it's not only modeling, it's the methodology, it's the process, how you do it. And I really recommend that you make sure you have clear process. For example, you might have a process called from information need to information product, where you really define how it's done. How are you getting the need from your users, how you are documenting that, how you are acquiring your data there, how you are doing the modeling, how you are delivering the data product to your customers, and what is the way how you are getting feedback when you have delivered it into production. What is the way to get the feedback so you can continue developing it. And my recommendation is that most likely you get best results if this process is led by internal personnel and you have consultants as flexible support, not owners of the process. Because this is the way how you ensure the long-term capability and organizational learning. You shouldn't outsource all of this. You should have this led by internal people and use extra hands where needed. So in the end, it's never just about the tools. Technology is an enabler, not the solution. And the real transformation, the real difference, what you want to achieve, it really comes with clear roles, ownership, repeatable processes, shared understanding of data's purpose. That's more or less what I wanted to talk about about our current topic here. Our case that supports this kind of methodology that Juha presented. Some words about D# in the end before we start the questions and answers. So D# is a frontrunner in this model-based business data platform thinking and tooling. We are growing fast. We are getting new customers, new partners, new people all the time. The company itself is started 3 years ago, but the tool is a little bit older than that. We think that we have unique approach and methodology to business data collaboration, conceptual modeling, and data warehousing. But everything we do, what we are implementing, is really based on standards. So we are using the best of practices in the industry there. We our main business is to sell licenses for a tool, but we support it with services. We have really extensive developer support. We have training program every month. We have several training courses. We have certifications, and we have these professional services where we help our customers and partners. We are not letting you get into any trouble, so you will always get help if you need. And we have something I told you that we are selling licenses. So these are the products that we have. We have DSAP Studio, which is the actual tool that we built the data platform from. Then we have DSAP Studio Modeler, which is part of the DSAP Studio. So with DSAP Studio Modeler, you can build the model, but you don't have the ability to generate the data warehouse. With Studio full license, you are getting the ability to do both. So you can model it and you can generate the platform with it. And with Modeler, you can only model it. And then we have this viewer, which is free of charge, just to view the models. So if you want to give other people in your organization a way how to look at the models, then the viewer is for them. So that's all I had to say. So I thank you for listening and joining in the webinar, and hopefully this was this information was what you were looking for. And now we will start if you have any questions. So let's see what we have in the chat. No,
Teromatti, I have at least something in mind.
No, yeah, please.
Yeah, because I was as I was watching your presentation there, I was thinking also of this because as you mentioned, this is way to kind of work from the business towards the data platform and so. But how do you see this? Because I see at many of my clients currently that these sort of large monolithic platforms are kind of starting to be somehow federated into maybe, or the ownership at least is being split into different business domains as it were. So do you see this sort of development that some parts of this overall conceptual model would be perhaps coming from completely different places, and that the ownership of the resulting kind of platform itself would be kind of split according to these different business areas?
Yeah. So for example, you are talking about something called data mesh or something similar.
Well, something similar, yeah. But even if without going necessarily into mesh itself, that the ownership of the platform is not split like according to the architectural layers, but actually according to sort of business areas. How do you see that?
Yes. We are dividing the model into submodels. And under submodels, you can have more submodels. So it's a hierarchical structure of the model there. And today, you can actually define even ownership of these submodels. So you can actually already now you can split that into responsibilities there. And that's something usable. Actually, we are doing in many customers right now. They are different departments that are in charge of, for example, this model you are seeing here, and others are responsible for theirs. There might be some typical classes that are used in all of those models, like here municipality or location or something like customer, employee, something like that. So this is also reusable things here. And you probably, in many cases, I see that there is someone who is responsible for these classes that are used all over the model. And this is a very interesting way to split things. And you probably should do it, because if your system is big enough like this, there is actually no central, you can't have one person that's in charge of everything. That doesn't work. However, thinking about the implementation then, that's another question. You can actually, in our system, you can actually implement any part of this anytime. So if you build, for example, only a couple of classes here, one person builds this red class here and a couple of these blue ones, they can make it. It doesn't break anything, and you can do that too. So it is usable here. Of course, it needs processes. It needs to say that you have to document it and be very careful there. But it's a usable approach. I really like that. Yeah.
Yeah. Sounds good. This is also kind of what I'm seeing, that increasingly solutions are being split into kind of business specific areas, and perhaps domains like in the mesh, perhaps into various sorts of data products or whatnot, but eventually all has to kind of everything has to connect, right? So as you said, there are things that are shared between different sorts of domains, and those also need to be defined and implemented in such a way that they can be shared and reused.
Yeah.
That's very good.
Any questions from the audience?
Doesn't seem to be anything on the chat, at least right now.
Yeah. Okay, if there's no questions, so we are ending this webinar. This is recorded, and I believe it will be available to all who have joined at least, and probably also those who have not joined but have told that will be joining. So hopefully everyone gets the recording afterwards. If you have questions, in the end slide you have my at least my contact information, and Juha can be contacted through the website of DataCore.
Yep, and you can also find me on LinkedIn.
Yeah, me too.
Yep.
Perfect. So thank you, Juha, for joining us today, and I wish everyone good evening.
Thank you.